we've got Mary jogging. It says Mary jogs 2 miles at 5 miles per hour. So 2 miles at 5 mph. That's a jog. And then she runs for 2 miles at 7 mph. Question: explain why her average speed is not 6 miles per hour. Well, come on, 5 plus 7 is 12, divided by 2 is 6. Well, doesn't work out that way. You can't explain in words why the average is not 6 miles per hour. The thing is to actually work out the average speed and then prove it that way. This is a high level question, and Part A does in fact ask us to do it. So Mary's jogging. This is her doing a jog, and this is Mary doing a run. Alright, 2 miles at 5 miles per hour, so a gentle jog, and a further 2 miles as she's running at 7 miles per hour, a decent run speed. Explain why her average speed is not 6 miles per hour. Let's calculate it. Let's work out the average time she spent, or the total time rather, she spent doing these runs. So I've got speed equals distance over time, so the time is going to be the distance divided by the speed. In other words, the distance is still 2 miles over 5 miles per hour, which is going to be what? Just call it 2/5 of an hour for now, alright? Okay, that's going to be 0.4 hours in total. That's for that part. Now, what about for the run? Well, speed equals distance over time, so time equals distance divided by speed, showing the numbers. Distance is 2 over 7. Let's put that into a decimal as well. So 2 divided 7 gives us 0.286, rounding to 3 decimal places, 0.286 of an hour. So total time is going to be 0.4 plus 0.286 gives us 0.686 hours of running. Total distance, well, it's 2 plus 2, which is 4. That's 4 miles altogether. So look at the average speed. So the average speed is going to be the total distance over total time. That's going to be 4 over 0.686. Let's look a little bit more like an 8 and less like a sausage roll. 0.686. Grab the machine. 4 over 0.686 gives us 5.83. Yeah, well, it's nearly 6, sir. Yeah, I know that, but it's not 6, is it? 5.83 miles per hour on average. Okay, so let's just backtrack. We have a distance and a speed, a distance and a speed. From each distance and speed, we can work out the time in each activity, therefore get the total time. We know the total distance, so the average speed would be the total distance divided by the total time, and it is not 6, so therefore not 6 miles per hour. Alright, so we proved it by calculation. Always the best way to do it, rather than try and talk your way out of it. Right, second part, very tricky I find. It says, I mean, even the wording is difficult. It says Mary wants to do training runs of about 4 miles, jogging at 5 miles per hour and running at 7. Alright, so let's just write it down. She wants to do 4 miles. How does she want to do it? She wants to do 5 mph jog, and she wants to do 7 mph run. Now, this is the punchline. How far does Mary go at each speed in order to have an average speed of 6 miles per hour? In other words, literally work out the true distances she has to travel, she has to run at each speed in order to average out 6 miles per hour. Remember, part A was about proving why it's not 6 miles per hour. Now we've got to get to the right figures to show that it is 6 miles per hour. Okay, so let's work out first of all the time, the extra time it takes. So let's have a look. I've got speed equals distance over time, and I know my speed is going to average out as 6 miles per hour, and I know my distance is going to be 4 miles. Alright, so here I go. So I want time equals distance over speed, and that's going to be 4 over 6, otherwise known as 4/6 of an hour. That's called 40 minutes. Alright, so if she's having to run 40 minutes for both little bits, we're going to dedicate 20 minutes to one activity and 20 minutes to the other activity. Alright, so let's just have a look. Let's see how far we're going to run. So for the first part here, for the jog, we have speed equals distance over time, and she'll be jogging at 5 miles per hour. So 5 equals distance divided by time. Now the time is going to be 20 minutes. In other words, 1/3 of an hour. Alright? So 20 minutes is 1/3 of an hour. So the distance she'll be running, or rather jogging, is going to be 1/3 times 5. Well, 1/3 of 5 is going to be 1 2/3 of a mile. Alright? 1 2/3 of a mile. 1.6 recurring miles. That is the jog. Now what about the run itself? Same thing. Run is going to be speed equals distance over time. So I've got 7. The speed is 7 equals distance divided by also 1/3 of an hour, because remember we're splitting the 40 minutes into 20 and 20 for each activity. Therefore distance is going to be 1/3, take it over and multiply, times 7. That comes to 7 over 3, otherwise known as 2 1/3 of a mile. Right, have we answered the question? We have. It says, how far does Mary go at each speed in order to have an average speed of 6 miles per hour? Let's just recap. I've used my 6 miles per hour to show that she has to be running and jogging for 40 minutes. So we have to assume 20 for each activity. So it's a 20-minute jog and a 20-minute. Is jog with 1 G? I don't know. Anyway, let's leave it like that. 20-minute run. So I've got my speed of 5 and my jog at 20 minutes, 1/3 of an hour. Therefore 1 2/3 of a mile jogging, and by the same calculation, using the 7, the speed for running, and the 1/3 of an hour, 20 minutes running activity, comes to 2/3 of a mile. So if she jogs 1 2/3 of a mile at 5 miles per hour, and if she runs 2 1/3 miles at 7 miles per hour, her average speed will be 6 miles per hour. So it's quite tricky working backwards. But that's it. That's the trickiest question, I think, in terms of compound measures, and it usually does involve speed or density. And if you're given an unknown formula, a different quantity you've never seen before, a different compound measure, then you'll be given the formulas, I'm sure. But you can expect speed or density to come up because it's in the book, it's in the spec. So that's it, and I'll look at the assess in a moment.